So I'm going to have an x plus 7 over 10 minus an x over 25 is less than 1. We're going to approach this the same way we would approach an equation. Right? We can eliminate the denominator just like we would with an equation. So we're going to treat the inequality the same way we would start off treating an equation. So I need to eliminate the denominator. What would be the common denominator for 10 and 25? 50, right? So we're going to multiply everything by 50. So we have 50 times the quantity of 10 plus 7 over 10. I'm sorry, x plus 7 minus 50 times x over 25 is less than 50 times 1. We're going to cross simplify. 10 goes into 50 5 times. 25 goes into 50 twice. So now what do I have to do with that 5 and the x plus 7? What do I have to do with the 5? We need to distribute it in. So we are 5x plus 35 minus 2x is less than 50. Combine our like terms. So we are at 3x plus 35 is less than 50. Yes?
Can I ask why we're using 50? Because I'm still kind of confused why we're using 50 instead of like 25.
Does 10 go into 25 evenly?
Oh, no, it doesn't.
That's why. So we don't want to still end up with like a fraction. That's why. All right, so now we're going to solve this just like we would solve an equation. So we are 3x is less than 15, so x is less than 5. How do I want you to write all inequalities, their solutions, as a solution set? So we are x such that x is less than 5. Are we ready for the next one? So now let's have 3x squared over 3. Oh, no, sorry, over 2. Plus 26x over 3 is greater than or equal to 2. Right. It's an inequality. We're going to approach it like we would an equation. We're going to eliminate the denominator, and we're going to do that by multiplying everything by what? 6. So we have 6 times 3 halves x squared plus 6 times 26x over 3 is greater than or equal to 6 times 2. We're going to cross simplify. 2 goes into 6 3 times. 3 goes into 6 twice. 3 times 3x squared is 9x squared. 2 times 26x is 52x, and that is greater than or equal to 12. What are we going to have to do? What are we going to have to do? Do you know?
We have to bring the 12 over.
Yeah, we're going to have to bring the 12 over so we can do what? Factor. This is a quadratic inequality. Who remembers when you're dealing with a quadratic inequality, what are we going to have to do? Test the regions. We're going to have to test the regions. Okay. So, anytime, once again, anytime you have a quadratic inequality, you must test the regions. Remember when we first did this, I said it's not going anywhere. It's going to keep showing up. It's going to keep showing up. We need to test the regions. So let's bring this 12 over. 9x squared plus 52x minus 12 is greater than or equal to 0. When we factor this, we're going to get an x minus 2 and an x plus 6. Since we want to be greater than or equal to, do we want our product to be positive or negative? We need it to be positive. We need our product to be positive. Now, the numbers I'm using here are just our reference numbers. So my first reference number is 2/9. My second reference number is -6. Who remembers how we test the regions? What sections am I creating? David.
Okay, so one of them is going to be less than, like it's x less than or equal to the -6.
Perfect.
And then you do like -6 is less than or equal to x, which is less than or equal to 2/9. And then x is greater than or equal to 2/9.
Absolutely perfect. Okay, so we're less than -6. Can I go -7? Sure. So we're going to have 9 times -7 minus 2. Do we agree that's still a negative? Yes. And then we're going to have -7 plus 6. Is that still a negative? Yes. So we have a negative times a negative, which is a positive. That means this one works because we want a positive. What else is going to work? X is greater than 2/9 is going to work. Let's check the middle one. I'm going to choose 0 for the middle number. So we have 0 minus 2 is a negative. 0 plus 6, isn't that a positive? A negative times a positive is a negative. So this one does not work. So now I have to write my solution in a solution set. So we're going to have x such that x is less than or equal to -6. Because they're not attached, what word goes in the middle? Or x is greater than or equal to 2/9. All right, let's step it up a little bit. So we have 10 over n plus 4 minus 1 over n is less than or equal to 1. Are we going to need to check for extraneous solutions? Yeah. Okay, but first we're just going to go about this how we normally would. Now, I saw this a lot on the test. If you have an n plus 4 and an n, your common denominator is not n plus 4. What would be your common denominator?
N plus 4 times
N plus 4 times n. Even if you said n squared plus 4, that's still not correct because if you're like distributing in that n, it would be an n squared plus 4n, right? But we never want it like the expanded form. We always want it factored, pulled apart, because that's easier to simplify. So we're going to multiply by n times the quantity of n plus 4. Actually, I'll just rewrite it. Bottom. So we're going to have n times n plus 4 times 10 over n plus 4 minus n times the quantity of n plus 4 times 1 over n is less than or equal to n times the quantity of n plus 4. All right, our whole point of doing this is to eliminate the denominator. So this whole n plus 4 cancels with this whole n plus 4. This n cancels with this n. All right, so what are we left with? We are left with 10n minus, is that negative going to get distributed? Yes, that negative is going to get distributed. So it's going to be 10n minus n, not plus 4, minus 4. Do we all see that? Is less than or equal to distributed that n squared plus 4n. What am I going to have to do? Yep, we're going to move the left side to the right side. Why am I moving the left side to the right side versus moving the right side to the left side? Yeah, we don't want a negative leading coefficient, right? When we're factoring, we need the quadratic to be positive. So we're going to move this whole thing over. So this becomes 9n minus 4 is less than or equal to n squared plus 4n. So subtract your 9n and add your 4. So here we're going to have 0 is less than or equal to n squared minus 5n plus 4. I'm going to rewrite it so it's a format you're used to seeing with the quadratic on the left side, but be careful when you rewrite it so the quadratic is on the left side. Isn't the inequality eating the quadratic? Right? It's like the crocodile mouth eating. So when you rewrite it, it still has to be eating the quadratic. So do we want the outcome to be positive or negative? Once again, we need it to be positive because it's greater than 0. And now we factor, easy peasy factoring. We're n minus 4, n minus 1, greater than or equal to 0. Our reference numbers are 4 and 1, positive 4 and positive 1. What do we have to do since it was a quadratic inequality? Test the regions. So we pick our smallest number, which is 1, and we're going to test n is less than or equal to 1. Then we test the quadrant between them. So 1 is less than or equal to 4, which is less than or, to n, which is less than or equal to 4. And lastly, we need n is greater than or equal to 4. All right, so we're going to test less than 1. If I'm testing less than 1, can I choose 0? Absolutely. 0 minus 4 is a negative. 0 minus 1 is a negative. A negative times a negative is a positive. So this works. What else is going to work? N is greater than 4 will work. Let's test a number between 1 and 4. Give me a number between 1 and 4. 2. 2 minus 4. 2 minus 4 is negative. 2 minus 1 is positive. A negative times a positive is a positive. This region does not work. Oh, sorry, a negative. You know what I meant. All right, it is a negative. That region does not work. So now we're saying we're going to choose all numbers that are less than 1 and all numbers that are greater than 4. But remember, didn't we have to look for extraneous solutions? So we have to see if there's any exception in our solution set. So look back to your original, look in the denominator. So we said all numbers that are less than, what was it, 1? All right, all numbers that are less than 1. Is there a problem here? All numbers that are less than 1. Yeah, what's the problem? Yep, n cannot equal 0, and what else? N can't equal negative 4. So what we're going to do is we're going to set up our solution set, and we're going to write n such that, and we're going to write it, n is less than or equal to 1, or n is greater than or equal to 4. But then what are we going to write? We're going to write n cannot equal 0, n cannot equal negative 4. You ready to try one on your own? All right, try this one. All right, who got an answer for me? Who has an answer?
Y is greater than or equal to 10 over 3.
I got the same, but remember, why such that, right? We want to write it in our solution set. Anybody? Yes.
I got 9 over 2.
All right, let's do it. What did you multiply everything by, David?
5y.
5y, good. So we have 5y times 2/5 plus 5y times 2 over y is less than or equal to? You forgot to multiply 5 on the other side. Anybody want me to keep going here? We're okay? All right. Sure.
So if it's not a quadratic inequality, you just solve it normally.
You just solve it normally, and if there's variables in the denominator, you check for extraneous solutions. Exactly. Nope, nobody needs me to finish this. All right, so the last part of this lesson, we're going to talk about literal equations. And my directions are going to be solve for x so we're going to have 2x over g equals t squared. Right, if I want to solve for x, that means I need to get x by itself and everything else on the other side. You're not done until whatever variable you're solving for is completely isolated. So now, if I'm going to get x completely isolated, I'm going to get rid of that g first. How do I get rid of that g? By multiplying both sides by g. So now we have 2x equals t squared over g. What are we doing now to solve for x? Dividing by 2. So x will equal t squared g over 2. Are we ready for the next one? So here I'm going to have ax plus b over c is equal to dx plus e.
I'm still solving for x.
Still solving for x. All right, so since I'm solving for x, I need to get anything with an x on the left side and anything that doesn't have an x on the other side. So in order to do this, I'm just designating the left side. It really doesn't matter. I'm going to get all the x's to the left. So I want to get rid of the c and the b. I'm going to get rid of the c first by multiplying by c on both sides. So these c's cancel, and then I'm left with ax plus b equals, what do you think I'm going to do with the c on the right side? I'm going to distribute it in. So that's going to be c dx plus ce. Remember what I said. In this scenario, I need anything that has an x. Anything that has an x, I need to bring it to the left side. So do you all agree I need to bring the c dx to the left and the b to the right? So that's what we're going to do. We're going to subtract the b. We're going to subtract the c dx. So now I'm going to have ax minus c dx equals ce minus b. Now, I need to solve for x, and remember what I said, we're not done until that variable's one variable completely isolated by itself. So what can I do on the left side? Claire? Good, we can factor out the x. So then we're going to have a minus cd equals ce minus b. All right, now I need to isolate that x, so what am I going to do? Divide by a minus cd. I don't believe on this test I ask for restrictions for the literal, but if I did ask for restrictions for the literal equations, what you would do is you would take the denominator, set it equal to 0, and then solve. So A cannot equal CD, right? A cannot equal CD. All right, last one. The absolute value of AX minus B is equal to C if C is greater than or equal to 0. Because it's an absolute value, don't I have to make two different equations? So we're going to have AX minus B equals C, and I'll also have AX minus B equals negative C, exactly. And what are we solving for? In all these problems, we're solving for X, so I need to isolate the X. So I'm going to first add the B over, so AX equals C plus B, and then I will divide by A. So the first one is X equals C plus B over A. That's 1. Now we're going to solve the other side. I'm going to again add B on both sides. So we have AX equals B minus C, and then divide by A. So X will equal B minus C over A. And if I asked for a restriction, what would be the restriction? A cannot equal 0. All right, so that is the end of day 1.